Listen. Today we will discuss about representation of. Today we will discuss about representation of truth table in K-map. That means how truth tables are represented with the help of Karnaugh map or K-map. So we are studying from very simple truth table, that is two variable gates and its truth table. For say we are taking OR gates, right? Or AND gate, whatever, AND gate. So this is the truth table for AND gate. This is the output Y. So Y is 0 0, it will be 0 0 1, then also 0 0 1 0 0 1 1 1. So this is one sample truth table, and how we can represent that truth table for the in a K-map, right? So first step is what? We have to identify how many cell K-map is required. How many cell K-map is required? So these two are input. That means you are getting the variables. Two variables present. So 4 variable K-map we have to take in this one. So this is 4 variable K-map. Point A and B will be in this way: 0 1 0 1. Next step will be what? We have to identify the position where ones are there. If we are assuming it is a SOP type expression, right? But for POS we have to find the 0th position and then we have to put particular 0 or 1 in that table. So right now we are assuming, we are discussing about SOP type expression. That's why we have to identify the output section, the position where ones are present, right? Because in min terms, 1 means it will be your 1 min term, 2 ones 2 min terms, 3 1 3 min terms, right? So what is the position? This is the third position or third cell corresponding to K-map. So rest of the position will be filled with 0 except the third position, because in third position of the truth table we have 1, and this position is nothing but A1 B1, so that is 3. In this way we can put the truth table, or we can basically use truth table and then simplify that truth table with the help of K-map, right? Now for a 3 variable, that means A, B, C, if you take the full adder, for say full adder, truth table of full adder, then output Y will be corresponding to the input 0 0 0 0, and output is again sum and carry form, right? So sum 0 carry 0 0 0 1 1 0 0 1 0 1 0 0 1 1 0 1. In this way we will get 1 1 1, that is 1 addition, right? So how we can represent this truth table? So here output 1 is what? Sum, and output 2 is carry. So we have to take 2 K-map of 8 variables, 8 cells, right? Because it is a 3 variable K-map. So K-map for sum, that means A, B and C. 0 0 0 1 1 1 1 0 0. So while we are calling, or while we are mentioning K-map for sum, that is what? We have to check the sum point, and again identify the position where ones are present, right? So what will be the reflection in the corresponding K-map? Here this is 0th position, this is 1, this is 2, this is 3, in this way this is 7. So position 1, that means 0 1, position 2 and position 7, 7 means 4 5 6 7. So in this way you can map the truth table in the corresponding table. Clear? So it will be same for 4 variable truth table or 5 variable or 6 variable, right? Now coming to the most important thing, that is the grouping of variables in terms of adjacency. Grouping of variables, or even you can get, that means how we can represent SOP expression and POS expression in given. Expression in given. That means separate treatment will be there for SOP and POS type of expression in given. না এটা তো 4 5 আমার আছে, মানে পুরোটা করলে পাবো না। Y it is 3, Y it is 4, Y it is 5, Y it is 6, Y it is 7. These 0, 1, 2, 3, 4, 5, 6, 7, these are what? These are cell number, and cell number are based on the corresponding column value and row value. That এই জায়গাটা 4 কেন লিখে why you are writing for it আসছে কথা বলতে পারি না 4 কেন লিখেছি that. So this is the cell. It has AB value 1 0 and C value 0. So 1 double 0 is what? Sorry, 1 double 0 is what? 4. That's why it is 4. Same thing. Whether we are writing 0, 1, 2, 3, 4, 5, 6, 7, it is based on the variables and its corresponding value in row and in column. Right? Now see how we can represent SOP and POS type expression in given. Right? SOP and POS type expression in given. How we can represent SOP and POS type expression in given. So representation of SOP and POS expression in given. Right. So first we are considering SOP expression. So what is the condition when we can use SOP expression so that we can simplify it with the help of K method? SOP expression means sum of product type expression. Sum of product type expression. So SOP, why we can write SOP expressions? When the condition is what? SOP expression can be either regular expression, regular SOP expression, right? Or canonical SOP or standard SOP expression. And what is the difference between canonical SOP expression and regular SOP expression? What is the difference? The difference is from canonical SOP or standard SOP expression, each term is nothing but main term. each term is nothing but min term. But in regular SOP expression, we can't say the terms are min term. Rather, we say it's a regular term. Because in regular SOP expression, we can't find every variable in every term. Clear? But in case of canonical or standard form of SOP, we are getting every variable in every term. So that's the huge difference. And we already discussed about how we can convert in regular SOP to canonical SOP. I think all of you know it, right? So first we have to check the SOP expression whether it is in regular form or canonical. If it is in regular form, then simply convert it to its canonical or standard. And after converting, you have to represent the canonical form of SOP in terms of min terms. In terms of min terms. For say, if the canonical expression is ABC plus A B bar C plus A B bar C bar, then its equivalent min term expression will be what? Tell me. Simplify it. Tell me. Its min term equation will be what? 7 1 0 1 5 and 1 0 0 4. Or if we arrange in ascending order, then 4 5 7. So this is the min term equation. So first convert the regular to SOP form, standard form, then convert the canonical or standard to min term form, then only use the K-map to simplify. Because in K-map we are not using variables, rather we are using min terms, right? So for this expression, how many cell K-map is required? 8, because 3 variable equation. So we have to take 3 variable 8 cell K-map, and the variables are A, B and C. Then 4, 5, 7. These are our min terms. Means what? In that position we have to put 1. Basically we are taking or highlighting these positions out of 8 cells, right? So 4, 5 and 7 means what? 2. Or we have to put 4, 5 and 7. It is again I am completing it 0 0 0 1 1 1 1 0 and 0. Now tell me. That means it will be highlighted by 1, then 5, then 7, 6, 7, 8. Right? After putting the variable, after putting the min terms in the corresponding K-map, then we have to check whether any larger groups are available or not. Yes, grouping is available. So what will be the output? Y. Let's tell. For this group, what you will get? You will get column value AB, that means what? A B bar, and row value is C, right? C. For this group, do you get any row value? No, because we are considering only the common. That means which are common, right? So for these two the column value was same. That's why we are writing A B bar, because if 1 0 is nothing but what? A B bar. You can use that form also. But for this one, C value is 0. For this one, C value is 1. Is there any common term? No. So there will be no C value. Simply move towards next group. So next group is what? These two one. So these two one has column value 1 1 and 1 0. So which one is common? A 1 reflected by A. And for C, clear? In this way you can represent your SOP expression and POS expression. For POS expression, the thing is different, means vice versa. That is what? For SOP expression or POS expression, you have to convert the regular SOP or POS to canonical form, and when it comes to the finding min terms, that means it is SOP. But while POS, that time it will be max term. And in case of max term, In case of max term, the rule is what? Complemented variables are represented by 1 and uncomplemented variables are represented by 0. That means these three positions will be 0 and remaining the min terms will be 1. So for this expression it will be like this. The max term expression for the above equation will be what? The remaining position except 4, 5, 7 will be 1 and 4, 5, 7 will be 0 and it is represented by pi of m. That means 0, 1, 2, 3, 6 and 6. This will treated as max term because these three are min term. So it's the opposite version. That's why 0, 1, 2, 3, 6 are the max term. Now put the max term in the corresponding position with the help of 0. Only we are changing 0 and 1 to differentiate between min term and max term. Rather everything is same. Right. So now tell me 0, 1, 2, 3, 2, 3 and 6, 4, 5, 6, 7. So these are the position where we have to put the max term as a 0. Because if we use both one for the max term and min term, then sometimes it will be difficult to identify which one is min term, which one is max term. Only for separation there will be 0 for max term and 1 for min term. Right. So what will be the group? Now tell me what will be the group? You can find a larger group and a smaller group. So what will be the output? Check. And here also thing will be different. 0 for uncomplemented variable because we are dealing with POS, max term, right? So tell me for this group what will you get? A plus for this group B bar and C, right? Again one thing will be different, the expression, because this is for what? This is for SOP, min term, right? But we are dealing with POS, so simply write this is the final. Clear? Clear? For POS, that means when you have POS expression means max term, that time the writing pattern of variables, common variables within a group and between groups will be this one. That means within a single group, that means this is a single group, what we are getting? Only A. But for this smaller group, we are getting row value as well as column value. So when we are writing row value, then it will be like this. And when we are moving towards column value, so in between you have to provide class. Clear? This is the basic rule when you have to represent SOP and POS expression in A. Clear? Just stop.